Hello everyone, good morning to all. In today's class we are going to start second topic of machine drawing, that is nuts. So let's see what is a nut. Nut is a machine element having a threaded hole that engages with the threaded end of the bolt. So nut is a machine element which engages with the threaded end of the bolt on the threaded end of the bolt. So this element is a nut, this is a nut, and this element is known as bolt. Now in case of bolts, as you can see, threads are external or external threads are there in bolts, and for hexagonal or for square nut will have internal threads. Next, chamfering. Chamfering is done on the upper corner of a nut by removing sharp corners to ensure the safety of the user. Again, if you see, these are chamfered corners. So to remove sharp corners of a nut, chamfering is done. Also for square nut, these are chamfered surface. So to remove sharp corners and to ensure safety of the user, generally chamfering is done. The angle of chamfer is 30 to 45 degrees with the base of the nut. With the base of the nut means from this plane. Now we have two types of nuts in our syllabus, square nut and hexagonal nut. Now what is square nut? As you can see, square nut is nothing but it's a square prism. It's a square prism with central threaded hole and chamfered at top corners. Similarly, hexagonal nut can be defined as a hexagonal prism with threaded central cavity or threaded hole at the center. Now assume that you have both square and hexagonal nuts with you. A square nut like this and a hexagonal nut. So you have a square nut and a hexagonal nut. Now the question is, which nut is to be preferred? Here, the spanner used for turning the nut can have better hold on a square nut than on a hexagonal nut, but the angle through which the spanner will have to be turned to get another hold in case of square is 90, but same angle for hexagonal nut will be 60. So if you try to open a square nut using a spanner like this, it's a spanner, just assume that it's a spanner, then the minimum angle to be turned will be 90. This will be the angle. How 90? Total angle 360 divided by sides of the nut. 360 by 4 will be 90. So for a square nut, the minimum angle to be turned is 90. But in case of a hexagonal nut, this is your spanner, right? So between opposite faces, we can fix this spanner like this. And here in case of hexagonal nut, minimum angle to be turned is 360 by number of sides. 360 by 6 equals to 60. So for a hexagonal nut, minimum angle to be turned or to turn the nut on the bolt or off the bolt will be 60. Similar to this, if you use a pentagonal nut, Say for example, we have a pentagonal nut like this. Let's say it's a regular pentagon. So for a pentagonal nut, the minimum angle to be turned will be 360 by 5 equals to 70. Similarly for octagonal nut, 360 by 8 and so on. So minimum angle to be turned is 60 degrees for hexagonal nut, and that is why this nut, hexagonal nut, is generally preferred. Now let's move to the problem. Draw to scale 1:1 the front elevation and plan of a square nut of diameter 40 mm, keeping its axis vertical and two of the opposite edges of the square face parallel to VP. So for a square nut, two square faces are parallel to VP and axis is vertical. So this is a square nut, and I will try to show you how these faces can be projected. The height of the nut is equals to B. Height is always equals to D. Sides of the nut or side of the base square of the prism is equals to 1.5 of D, 1.5 of D and 1.5 of D. So these are sides of the square of square nut, 1.5 of D, right? It means the diameter of chamfering circle is also 1.5 of D, right? And curvature. So from the central line, see, this is the center and this is the radius of curvature. So this radius is equals to radius R is equals to 2D. This R, radius of curvature for square nut on the faces is equals to 2D. And here for threads we'll have two diameters, 0.8D and D. D is the diameter of major or outer circle or crest circle, and 0.8 is the diameter of minor circle or root circle. But in case of nuts, root becomes crest and crest becomes root. So just remember that you are required to draw two circles for representation of threads, for internal threads and for external threads. Now please assume that this is the square nut which is resting on its base on horizontal plane, and two opposite faces, square faces, are parallel to vertical plane. This is vertical plane and axis is vertical. Now try to project its front view from this direction or from this direction and top view. So that will be your answer. Now for projection, first of all, please calculate all standard dimensions. So first is D, given diameter is 40 mm, then 0.8 of D will be 32 mm, next is 1.5 of D, 60 mm, and radius 2D. 2D is 80 mm. Now in the first step, please draw reference or XY line. This is your reference or XY line. Next step, we will start from its top view. So please draw axis, vertical axis of the nut. So please draw vertical axis of the nut like this, in front view and in top view. Right. Next step, draw another center line for the top view So this is the center. This is the center of this nut, right? Now from this center, draw three circles of diameter 0.8 d. First circle of dia 0.8 d, second circle of dia d, and third circle of dia 1.5 d. All three circles are concentric circle. So first circle of dia 0.8 d, that is 32 mm. 32. So we'll take half of 32, 16 mm as radius. Then next circle of diameter d equals to 40 mm. But it's an incomplete circle. It's an incomplete circle. And third diameter 1.5 d or 60 mm. Again, it's a complete circle. So draw third circle of diameter 1.5 d like this. Now please remember that incomplete circle with diameter d is representing internal thread. So for internal thread, this circle will be incomplete or discontinuous, and for external threads, in case of bolts, this circle will be incomplete circle. And here we have a nut. So please draw first circle of diameter 32, it's a complete and dark circle. Second circle with diameter 40, incomplete, and thin circle. Thin means please use thin line or medium dark pencil. Then for chamfering circle, the diameter is 1.5 d or 60 mm, and it's a dark and complete circle. Now from all four points of intersection of axis and chamfering circle, draw lines parallel to first and second axis or parallel to and perpendicular to XY line. So from this point, draw line. I use a scale. So parallel to XY. And perpendicular to XY. So this is the top view of your square nut. Now for front view, please extend all corners or all limits of the top view. So from this end, or simply from the center, first of all mark a height of d along center line. This is the height d, and up to this point extend all corners. So from the last end, extreme left and extreme right, and then draw a line parallel to XY from both ends. Right. Now this rectangle is the front view of square nut. So we have to show all visible outlines using HB pencil. Next step, we know that for front face, 2r is the radius of curvature. So from the center, from the top center or from the top end of the axis on this side, or from the midpoint, mark center of this arc 2d apart. So from this point 2d, mark center, and from this center, this point as center, and this much means 2d as a radius. 2d is 80 mm. So 80 mm is radius, and center is this point draw an arc. And for internal thread, please catch limits of major and minor dia and draw hidden lines throughout its height. Okay. So this is the final front view and top view of hexagonal nut, which is resting on its base with axis vertical and two opposite square faces or faces of square nuts. These two faces are parallel to VP and other two faces are perpendicular to VP. Next dimensioning, height is D, height is equals to D, so write D, diameter, extend it, similarly for D, extend it and write okay, you can use a leader line like this. Dia 0.8 of D, 0.8 D. And here the dia is D, dia D. And side of square is 1.5 of D, 1.5 D. And last, the radius from the center to the arc. Radius R equals to 2D. Radius R equals to 2D. Next, table for standard dimensions. Please draw a table for standard dimensions showing all standard values in the table. Write D, then 0.8 of D, next 1.5 of D, then 2D, D40, 0.8 D, 32, 1.5 D, 60, and 2D is 80. Now heading of your answer, please write square nut across flats. Square nut across flats. So once again I'm going to repeat steps for you. Please calculate all standard values d, 0.8d, 1.5d and 2d. Please draw xy line first, then start with top view. Please draw three concentric circles of diameter 0.8d, d and 1.5d, where second circle with diameter d is incomplete circle. Please use medium dark pencil. Then please draw a square through all four midpoints of the circle or points of intersection of circle and axis. Then please extend these limits for front view. Height of the nut is d is equals to d. So extend it for d, extend it for d. Then from this point along central axis, vertical axis, from this point mark center of this arc at a distance of 2d, r equals to 2d from this point. So this height or this distance of the center from top end is 2d. Then from the center, r equals to 2d, draw this arc. And then finally show hidden lines for threaded holes using these two limits, left side, and these are limits for your right side. And then if possible, please draw front view, then top view. Then after top view, just below this top view, construct this table for standard dimensioning and write its heading just after the table. It is not possible in my case, but if possible, please follow these instructions in your sheet. Now I'll request you to please draw this problem in your sheet. And if you have any problem, any doubt in this problem, please write your comments in the comment box. Thank you.